So in our lineup of intermolecular forces, we're going to talk about first ionic intermolecular forces. So what is an ionic compound? Well, formally it's kind of defined as a metal bound to a nonmetal, but this is kind of misleading because there are metals that bind to nonmetals that form covalent bonds ionic. So really we're talking about extreme here. Column 1 and most of the column 2 metals, so lithium, sodium, potassium, rubidium, strontium, beryllium, magnesium, bound to something on the top right part of the P block. So chlorine, fluorine, oxygen, something like that. In these types of compounds, we have a truly positive compound, which is the metal, bound to some very negatively charged atoms, which are the nonmetal. We have true charge separation, we have ionic bonds. These will represent the strongest intermolecular forces, and this is because they don't give charges back. This is truly an electron transfer from one atom to the other. So if we look at something like sodium chloride has a really high melting point because we have all these positive negative atoms that are bound to each other like magnets. So if you've ever taken a box of magnets, throw them on the table, they don't move that much. Like they're just solid rocks of magnets bound to each other. Same thing's going to be true for our ionic compounds. In order to get these charges to pass each other, we have to have a really high amount of energy so that they're vibrating so fast that those positive negative differences don't matter anymore. Now, the thing about ionic compounds is that's really all there is to it. If we see a metal bound to a nonmetal, we will say this is an ionic compound and it demonstrates an ionic intermolecular force.